Hi everyone, welcome to the GraphQL 101 from Backend to Frontend chat. So we are going to present what is GraphQL, how to connect it. I'm here with Agustin Mulet.
Hello everyone.
So to introduce us ourselves, I'm a senior software developer here on Softvision. I'm tech and team leader on some of the teams. I have experience mostly on the Microsoft stack, which is .NET, .NET Core, Azure, and the SQL of Microsoft.
And I am Agustin Mulet. I'm a software developer here at Cognizant Softvision. I also have a role of community lead for the web community. I have experience working with Angular, React, and can give a hand on .NET Core and Node.js stuff on the backend. Yeah, that's me.
So, what is GraphQL? So at its core, GraphQL is a language for querying databases from the client-side application. On the backend, GraphQL specifies an API to present the data to the client. GraphQL redefines developers' work with APIs, offering more flexibility and speed to the market. It improves client-server interactions by enabling the former to make precise data requests and obtain no more and no less, but exactly what you need.
Yeah, it was created by Facebook in 2012. And GraphQL was first used internally for the mobile applications to reduce network usage by means of its specific data fetching capabilities. And since GraphQL specifications and reference implementation in JavaScript were open sourced in 2015, major programming languages now support it, including Python, Java, C#, Node.js, and more. And the GraphQL ecosystem is expanding a lot with libraries and powerful tools like Apollo, Graphical, GraphQL Explorer, and a lot more that we're going to see.
Yeah, the key part of GraphQL is that GraphQL is a specification. So it specifies how to connect the backend to the front end and perform data queries, not to the database, but through the front to the backend. So key factors of the GraphQL are which the benefits the front end and the backend. The first one is the single endpoint. So if you are used to REST API, you know that you have the HTTP methods, actions, which allows you to get data, to put new data, to update and delete the data that you have. Here, in the REST APIs, you need to have controllers, you need to have endpoints for each of your entities that you want to get, to retrieve, and to update. Here, everything's changed. You have a single endpoint, which is a post endpoint that you can hit and update your data. To get your data only through queries that we are going to see on the next slides. The second point is that it helps APIs, defining APIs, because it provides a flexible data structure. That means that from front-end, you can query whatever you need and no more, no less. That's important because some points that we are going to see after. In backend is more difficult, but you can also get a fixed data structure that the frontend can use to retrieve the data or update it. So what I was referring to before is the overfetching and underfetching. So if you are on a REST API and you need to get data, you sometimes are on the battle that you get the user's ID. To get the user post, you need to hit another endpoint. And to get the description of the post, you need to hit another endpoint. So that is under fetching because you are not getting the data that you need on the first query or on the first data retrieve that you are asking to the backend. And overfetching means that you are getting more information that the information that you are needing, the information that you are going to use on the front end. And that's also is bad because you are, well, traveling that data through the network. Sometimes it's sensitive, and also it's increasing your package size and your time to get the data because it's more heavier the package. So, Agus?
The next one, it reduces amount of data that needs to be transferred over the network. Just as Ivan said, you query exactly what you need, so you're not going to bring more data from what you really need. For example, if you need to only show the name of some users, you may query for only the names of the users, and that's a lot of data less that you're querying from, I don't know, a REST endpoint that gets all the users' data. It can be implemented in almost all front and back frameworks. And there are libraries to connect GraphQL with mostly everything right now. We have something for Firebase, for, I don't know, a lot of programming languages. And there's no need to modify REST API endpoints anymore. If you need more data, you can ask, if you are a frontender, you can ask your backender friend to add some, I don't know, if you need to the users to start showing the age of the users, it's going to be added to the users entity, and you don't need to make another endpoint or something like that to only check some things like this, and you don't have to wait to the endpoint to be finished to start working on the front end, which is very cool.
Yeah, if you are a backend developer, you may know that every time that you are asked for a new feature, you need to modify the controllers, the entities, the view models, or the contracts. Here, if you have the entities mapped to the resolvers that we are going to see on next slides, you are okay. The front-ender can query the data, and that's it. You don't need to modify the backend. So that is very flexible because you get the data whenever you need from the front end. You can modify the application as you want.
Yeah, and also you have discussions about how the shape of the data will be and not what the endpoint should return.
Right, that's 100% right. Yep. So we are going to see a bit of the query language that GraphQL has. So I will keep it simple. If you put an exclamation mark, it means that the data, the type of data will be not nullable. So here I have an interface, the character interface. As in every programming language, the interface works on the same way. You can have, well, the ID, which is a data type, the string, and object data types or entity data types. And you can create a model for your interface character, and you can implement it here on a type. A type is like an entity, a class. The human class implements the character, and I'm using the same attributes that I declare on the interface, and also adding new attributes like starships and total credits. So Droid implements character as well, because human and Droid are the same type of object. It doesn't implement starships and total credits, but implements primary function. So that's the way you can use GraphQL to perform interfaces and types. In the next screen, I will show you how to perform a queries. So here I'm querying for the hero, which I want to get the name of the hero, and the friends, which is an object which is returning me here an array of friends. So the data return comes out back from with a hero, R2D2, and the friends is an array of Luke Skywalker.
Yeah, what we see left is the query, and on the right, the object of the response.
Right, yeah. You can also use arguments, which will be used on the query to get the data from the backend. Here I'm querying for the human with ID 100, 1000, 1000, sorry, 1000. Getting the name and the height. And the response is that, the human, the name, and the height.
Yeah, also we have aliases and fragments. The alias provides you a way to rename a returning object. For example, if we want all the heroes, but that are in the episode Empire, we can use Empire Hero to be the name that are going to be returned, well, of the name of the object that gonna have the data inside returned from that query. Also, the fragments allows you to reuse parts of a query for constructing other bigger queries.
Yeah,
so
sorry, go ahead.
If we need to, for example, query some parts, we can predefine these fragments. If we need to query some parts that we're going to be querying often, we can define a fragment, and we can use it there with the 3 dots, kind of like spread operator, that shows what things are going to be queried from, for example, these heroes. In this case, name appears in friends and name of each friend.
Yep. We'll be using fragments on a later query, so you can check how it's working on the actually.
It's like a form to group some stuff to query. Fields to query, sorry. And next one, mutations. We have on the front end the CRUD operations, but for example, the queries are only used for the read part, and for the create, update, and delete, we're going to use mutation because we're going to mutate our data. As it says here, mutations are the way that GraphQL has to change or persist, insert, or update data on the backend. This can be done using the reservoir mutation instead of query at the first part of our mutation right now, not query. Just like in queries, the mutation can return an object type. That depends on how the backend is defined, or well, the query or mutation is defined in the backend. And you can use this data on the front end to, I don't know, maybe check if a user was deleted, which user was deleted to eliminate it from the front end, or maybe add it to the front end when the query returns something, kind of like an optimistic update of the front end, and things like that.
Yeah, only to read this slide, the leftmost image is the query, well, the mutation in this case. The middle image is the arguments or the parameters that you're sending to the query or to the mutation in this case. And in the right part, the last image is the return that you are getting after creating the mutation or the new object. I will be using this on live, so you're going to see how it's working. So what is next? We have a large set of tools that you can use on the backend. You can raise an Apollo server. Hasura is great because allows you to get data from any data source. It makes the data available on a GraphQL endpoint. So you can connect with your data source. Hasura allows you to query directly to them. That's it. It's great.
It's in the cloud.
Yeah, it's in the cloud. Prisma is a database toolkit that aims to replace ORMs. GraphQL Yoga is a fully featured GraphQL server. Well, you have middlewares and ORMs like Express, Happy, GraphQL Apicoa, SQLize, FireQL, which allows you to connect to Firebase.
Yeah, now how do I query things on the front end? Because we need a way to access all this stuff. We have the Apollo client, which is I'm going to read what the Apollo client web says. Fully featured, production-ready caching GraphQL client for every UI framework and GraphQL server. Wow. We also have Relay, which is made by Facebook. It's a JavaScript framework for building data-driven React applications. URQL is simple, minimal caching GraphQL client for React also. We have Prisma GraphQL request. It's also a minimal GraphQL client for Node and browsers, and React query that is a pretty new tool that it's being used a lot and has hooks for fetching, caching, and updating asynchronous data in React that supports GraphQL, REST, promises, and a lot more. Also, we have another tools that uses GraphQL. They are not GraphQL tools per se, but they provide us with tools to query things, or well, they used GraphQL on the inside. AWS Amplify has some tools to query through GraphQL. Gatsby queries everything via GraphQL. Could be pages, could be images, could be. It's a nice tool to level up on GraphQL. It uses React, and GridSum is the same mostly as Gatsby, but uses Vue. And if you need more tools on that link, on that awesome GraphQL, you have a lot of tools from the front end, for the backend, and a lot more from another programming languages like Golang, Python, Java, a lot.
Mm-hmm. Great. So let's get started with the fun part. Let's check the backend code. We'll skip this one. Well, here I will jump to the Visual Studio. I have my solution here. I'm using the Norwind database, the Norwind data repository, which is the Microsoft 1990s data set, for example. Well, I have some key parts to define a GraphQL application, and I will show you how it's being done. First of all, you need to define a schema. The schema is the way that you connect the schema itself, the query, to the resolver, and you define the type of the query. And in the same way, the mutations. You need to define the mutation connected to the resolver of the mutations. So as I had the schema, I had the Norwin query, which is this element here.
They are asking if you can zoom in a bit on the fonts.
Sure,
if you can
great.
make it larger.
Go, that's it, great. So I will show the schema again. I had the query mapped to the resolver. I have the mutation mapped to the resolver. So this resolver, the Norwin query resolver, I have it here. And I have a field, which is the property, the product type property, that is returning me the all products. When I query products, I will return all the products from the product repository. I have the same for orders. When I put query orders, I will get all the query with the details. And I can have the order, which I'm using a single word, because I can put the ID as a parameter and get just one order, depending of the ID, the parameter that I will send. I had the same for regions. I can get all the regions using the query regions. The mutations, I have the same, but to create the region and delete the region. I will show this on example on most detailed after we can see the code running. So I have here a playground. This is a Nugget package that you can install. Here I have the tab queries which I have the fragment, the order fragment, mapped to order type. Order type. I will show that order type is. So it's important to know that we have the schema, the resolver for query and mutations, and after I have the types, which is a way to map the entity fields to the query GraphQL fields. So in this case, I have the order details, order ID, order product ID, the quantity and the unit price mapped to an int and decimal GraphQL type. I have the order type, the order ID and the customer ID, the product type as well. I have everything mapped. I need to do this for each entity that I need to query on GraphQL. Yes, I know it's a bit of work. It's not that compliance with the slide that says you don't need to modify anything. Yeah, you need to modify on backend, but you can make available all the data that the frontend, your friend frontend is needing for the application. So you do it once, and it's for everybody, available for any time. So you have the types which are used for querying, and you have input types, which I have in another folder, that allows me to map the possible input of a new region in this case, which is asking me for an ID and a description. So as I showed before, I have the fragment, the GraphQL playground, and I have the fragment, which itself, it does nothing, but when I put it on a query here, or the fragment, it will return me all the orders. So as you are seeing, I have the data, return me all the orders as an array. I have each object, we have order ID, order date, customer ID, and an array of order details. If I go here and, I don't know, put a comment on order date, this will disappear. Great. So what it does on the real life, when I comment this, I am transferring less data. It will go faster. This is only for transferring through network. You need to remember that here on the backend, when I execute a query, I'm doing the same as always. I'm getting all on the repository. So the query will be huge. Yeah, you will have a huge query on the database, but the transfer to the front will be less data. So here is a difficult part for backend developers, that you need to plan your calls to the database to make it more efficient, because you are getting all the data just to transfer chunks of data to the front end. So you need to plan it to have different resolvers like products, orders, but with less data, because the call to the database will be huge on the backgrounds. So going back to the playground, I have all the orders. I can query for a single order, which is this query. I pass in the argument ID and pass in the ID of the order that I want to get. And for the fields, I'm using the fragment. It's the same that copying this and replacing here. The same functionality, but well, on a fragment. I can query the whole products. It's pretty much it. It's not that difficult. So I will jump to mutations, because as you see, it's very simple to query data. You can define which structure do you want, and it's only returning you whatever you need. So here I have the region fragment, as you saw before, and I have a query to get all the regions. So I have the 4 regions, and I want to create a new region. So here I have the query variables. I create a new variable called reg, which has an object with region description, test, and the region ID, which is 5. 5 is not existing here. So when I execute the add region, reg will be replaced with the query variables here. We'll be replacing here the region input that I specify on the backend here.
That's the data type.
Right. The data type is region input type. I define that here, and I'm writing the same that I put on the backend. So create region is the reservoir for creating a new region. This is on the mutations. Here, create region. And this will be creating me a new region with the region input data type. So it's expecting a parameter which is called new region, that is also seen on the backend. This is the argument that it's expecting. If I go back, I will be returning the region fragment that I defined before. So when I execute the R region, it will return to me the new region, but not the whole list of the regions. So I need to execute again the get regions. And I'm seeing here the test 5 region that I added. And in the same way, I have mutation for the delete regions. This is called remove region, and it's using the mutation reservoir delete region that I can check here on the backend. Delete region is expecting an argument called ID, which I'm passing through here directly to the query, and I'm not using query variables. And I'm returning a region fragment of the result of that query, which should be null because I'm deleting a region. So if I remove the region, I'm getting a null. If I get the regions again, I have the 4 regions again. So this is an example, but you can modify the backend as you please. If the frontend is planning the frontend to be, when I delete a region, I need to get all the regions again. Okay, you can perform that modifications on the backend, and that's it. You can do whatever you need with GraphQL. I need to say it again. As a backender, you need to be very conscious of what you're doing, because you're getting less data transferred to the network, but the queries to the database are the same. So you need to plan it on on the afterwards. Another thing that I want to show you is I have here on the playground 2 tabs, which are docs and schema. If you are a front-end or you are not getting access to the backend, or your backend friend is not responding you the Slack channel, you can go here and see the documentation. Here I have the queries that I can hit. I had the query, the order query. So I can go back to queries, docs, and I can see what the order type has. So in this case, I can create this fragment using this documentation. I can hit the orders as well using this type. I can see the schema to know how to hit orders expecting our order type, which we showed before, which is this one. This is the order type. Yep, that's it. You have the documentation here. So it's very simple to know what the data is, what the data is providing you from the backend, which data is providing you the backend. So as a front end, you are very free to work as you please with the data that the backend has available to query. If you are not seeing anything that you are missing a field here on the documentation, you need to ask the developer, the backend developer, to make a new resolver or put it here on the types. You need to modify the types and create a new mapping for the property that you are missing. Or if you are missing an entire entity, you need to create a new query, a new resolver, which is this one, and a new type for returning the data. And if you need to make CRUD of that entity, you need also to create the mutations and the input types. But it's very simple. Again, you have the schema, the query, mutations, and the types. That's it. That's pretty much. For Nugget packages, you have the GraphQL Nugget package. There is not much else. So I will jump to the Postman to show you that you can use as well the Postman to perform queries. You have to put the endpoint on post, because you remember that I said there is no gets here. You have one single endpoint and it's only post. And on the backwards of to the single endpoints, to the common endpoints, REST endpoints, I can have an endpoint here, which I have on the code, the values controller here, which is returning me everything. I can also have on the same code the GraphQL endpoint, but on the GraphQL endpoint, you only will work with post. And here on Postman, you will have to select body and GraphQL. That will enable you these 3 boxes, which is the result here on the bottom part. On the right part, you have the query GraphQL variables, which is the same that we were seeing here on the mutations. Here on the left, you will have the query or the mutation that you need to hit. So if I send this one, I will get the same data, but using the Postman, which allows me to see the size, the time, the response, everything. So that's it for Net. So I will jump to Node. We have a small application running Node, which will allow Agustin to show the front end. But as I said before, we have the same types, the same type of structure. We have the schema here on the backend on Net. The schema, which says the query, the mutation, mapping to the resolvers. So I have the schema, which says the types and the resolvers. After I have the resolvers, which in this case I have split on queries and mutations, and in Node I have the queries and the mutations on the same file. I have a query for all the users, which is using the user model find for everything, and the user, which is expecting an argument called ID, which will execute the find one using, well, a feedback, and it will return one of the users. For mutations, I can execute the add user and add post because the user has posts associated. To see that, I will jump to the definitions, the type definitions, which are the same that we were seeing here. I have the query users, which is user, which is expecting an ID of type string. And the users which will return an array of users. In this case, we return one single user. And I will define what a user is, what a post is, how to input a new post, the mutations to add a new user and to add a new post. After that, you have the entities, the common entities, the ID, name, address, birthday, and the post ID, title, content, comments. And I can hit this using Postman to the localhost 4000, and I can send this one. Yep, and it's returning my name and my address. This is connected to MongoDB database cloud. So well, it's returning me everything very quickly. So that's pretty much for backend. You don't need to do anything else. You only need to be conscious of the data that you're making available. If you have any question for backend, you can chat me through Slack, send me an email. I will forward, or I will show my email on the last slides. And I will let you with Agustin, which it will show how the frontend works. Hope you are enjoying the presentation. Thank you.
Let me share the screen. You have some questions about mostly backend. Maybe you can.
Oh, yep, I will chat them. Thank you.
So, well, here we are. We have the server, the GraphQL server that Ivan just showed of Node.js. Let me know if the font is small. We have it running on the port 4000. And we have an instance of MongoDB running that we had connected here with, through Mongoose. And we can access the playground just like Ivan showed. We can query the users. I only have one user, as you can see, MongoDB user. If we run the query, we got that single user. And what I'm going to show now is how to having a React REST application running, how we can convert it to using this server, to use this server via GraphQL. So as the backend, I'm using a JSON server. I've already have some packages installed for using Apollo. You need to install @apollo/client and GraphQL to use to define the queries and mutations on the front end. And in an environment variables, I have what will be the server URL right now. This is defined by JSON server. If we go to localhost 3000/users, we have a collection of users defined here. JSON server also allows us to define, for example, to query a single user through the search params. I don't know, ABC is the first ID. So we have this single user. Well, after that intro, we need to start to work on the Apollo client side. So I already have it installed for the sake of time. And we need to start importing. Oh, damn it. From Apollo client. We are going to need an Apollo client to define a new instance of our client, an Apollo provider to wrap our app on this provider, and Apollo is nice enough that it provides us with some cache, and we're going to see that we are going to use this cache instead of the state in React. As we said, first we define a client, which is going to be a new instance of Apollo client. Oh, damn it. Apollo client, which takes an object as an argument with some key values. The first one is going to be the URI, which we define in our environment variable. We need to process and dot server URI. I don't know if this is going to work. Maybe I should use template literals. Well, just to be sure. I know that this works. Maybe it's overkill or not necessary, but we're going to use it anyways. And after that, it receives also the cache that we just talked about, and we need to define a new instance of in-memory cache. So now that we have our client configured, we need to wrap our application with a new wrapper. I'm using these wrappers that come from Chakra UI. It's a component library. It's pretty cool. You may want to try it. So we wrap with the Apollo provider, and we set the client prop with the client value. Oh, we can send this down. Sorry, I'm not used to use a Mac, so I may do some stuff. That's it. If you save this, now we're going to have the application wrapped in the Apollo provider with the client configure. That's the only thing we had to do to configure Apollo to be ready to be used. If we enter to our URL to our app, oh, sorry. Our app is running in localhost 1234. This is a parcel app. Oh, shit. That's it. It has dark mode. And we have the first part reads all users. I've added this because the JSON server returns the data super fast. So if I didn't add a 2-second set timeout, we couldn't see the loading state. We can check certain user by ID, for example, this one, which takes the ID from the params. we can create a new user and delete certain user. We are not going to do the update part on this because it's going to take, I think it's going to take a lot of time. That might be for another talk. And if we check, if we inspect, we can see on the network that all users is being requested from the localhost 3000, our JSON server. We're going to change that. I have this user component, and we're going to, for example, check how to query all the users. If we have the playground at hand, we can check it there. But if not, Apollo provides us with a nice plugin for the browser that has Graphol, which is another tool that's a lot like this GraphQL playground, but has some differences. So we're going to start deleting this. We can delete this state, the use effect also. We're going to take care of everything. And now we're going to import from Apollo client some helpers to start making the queries. Apollo provides us with a hook that is useQuery, and it provides us with the GQL tag, template literal tag. Template literal tags, what they do is they can convert a template literal that we are writing, and this might add some helpers or some things, some stuff that Apollo needs to do that query. So we can define, for example, out here, our query get users, which is going to be a template literal with a tag, and we can just simply take this query that we know it works and paste it here. So to make this query, we're going to destructure the usage of useQuery, and the useQuery takes a query as a parameter. And if you need some options, we said that the query is going to be get underscore users, and this returns three things: a loading state, an error state, if there's any, and the data. So its loading is not going to be used by a Boolean that we define, so it's going to be managed by the loading state of the Apollo hook. If there's an error, we can return a box, align self-center. These are stuff from Chakra UI that says Sorry, there was an error fetching users. And now we said that the data is going to contain what comes from this query if everything goes right. So we are saying here that we are querying for users. So in data.users, we are going to have, as we saw here, an array with objects of all the users that are living in our MongoDB instance. So now we are on the users part, and we see the 3 users from the DB.json. If we change whenever we use users to data.users, if I save this, this should work and only bring us the MongoDB user. And that's how you change a component that had a use effect, use state, and some other stuff to use just one hook that Apollo provides us with useQuery. And this is already using a cache to put these things and not query every time that we enter the users. If it can get the data from the cache, we take it from there. And if not, we're going to see after this how to update the cache, sorry. So now we have the reader users using our GraphQL endpoint. We're going to pass now how to read a single user. This might be a bit more verbose, but we're going to see that it's practically the same that we have just done. We can just, I cannot enter in a single user right now because it's going to send an error. We don't have this ID living in our DB.json, so we're going to go back. But to fetch a single user, we can check on the playground if we have access, or if we have the, as I said, the plugin, we can use the plugin with Graphol. As we are testing this right now, I'm going to check here in our local playground, and we have the query to fetch one user. The user needs the ID, which is the type of string, and will return one user and can provide us with all these details from a user. So we're going to change this query. This is the name. We can put it any name you want, any name. But here we need to use the real name of the query that we are using. So we're going to fetch a user. We're going to say that the ID value is going to be equal to a variable ID, but says here that is not defined because we need to tell our query that we're going to receive an ID value and it's going to be on the type string. So now this could work, but the thing is that since this is a variable, we don't have it defined, so it's going to fail. Oh, sorry, I killed the. Whenever there's an error on this server, it just explodes. So we're going to define a query variable here with the name ID, and let's just check the ID from here. Oh, well, sorry. We can query users. Let's just check the ID here. And we can paste it here. So now if we, well, let's just rename this a user. Oh, what happened? Sorry. Let me check my notes. I don't know why this isn't working. You're checking this? Are you checking this?
You have
Maybe
it showing. Do you see if the GraphQL, sorry, the node is live, is working okay?
Yeah.
The console?
Yeah, I defined the ID of a string, user ID.
Let me check real quickly here on local. You're sending a string and not a GID, I think. You need to define the ID as an ID, I think.
No, it says
Oh,
here
string.
it has
Right.
to be a string. Well, I was prepared for this kind of stuff, so let me throw this down, and I'm going to make a git checkout to read single. Oh, sorry. Git stash.
Oh, you put the ID variable on the HTTP header section in the playground.
Oh.
Thank you, Dan Corneliu Popa.
Thanks. Now it should work.
I will, okay, great, thank you.
Now it's working, we can roll back. So if we continue, we can just make as we made here in the users type, get all of this stuff. Sorry, users. We're going to delete the React hooks. This should be still working. It's working okay. We are going to delete the usage. This yes effect is going to disappear also. And this wait helper is going away. Let's just paste. We import the hook and the tag. We can come here to the playground, get the query, update this one. And the difference with we just did is that the usage of the hook loading error data.
You put const instead of const.
Thank you.
No worries.
Use query. And as we said, use query. As we say, the use query gets as a second parameter. Let's just change this name. Get single user. The first parameter is going to be the query, and the second parameter, an options object with, for example, variables, which is what we need to pass to our query. The thing is that the ID definition is down here, sorry. So we send the ID as a variable fetched from the use params. This is the hook from the React router DOM. And there's not much more to do except changing this thing. We can fetch the error from here. There was an error fetching that user. And as we said, if we have the data will live in this object data, user, and all of this stuff if the query comes with some things. So everywhere we use user, we can just destructure it from here. Don't do this at home. And we don't have to add data here. I first check if there is a user existing. Don't use the destructure here. If we save this, I think that the server updated. And now, oh no, sorry. Missing user options. I will stop it and run it again. Whoa. Well, we had an error fetching that made, yeah. I mean, this server with no error handling. Well, it failed. I would change to the branch that on this, on which this should be working. Slash check out. So split single. Let's just do npm run dev. After the talk, I'm going to share the repos from all of this stuff. I can assure you that these repos were tested before doing this. Live coding is really hard. Starting. Listening. And let's check. And that's it. Maybe the destructuring was not being correctly done. But if you add data user as said here, it all worked. So let's continue on the next part. The create user. This might be the hardest part because, as I said, we need to run the mutation, and after that, we have to maintain our cache updated. So we're going to create new user. For now, we have the ID, JKL, name, hello, address, something, 24, birthday, 26, September, my birthday, submit. Thanks for using this super secure software. If we check the DB.json, it's here. Okay, we need to change this to use a mutation here on the create user. Please don't do this at home also. This is a check only for this demo. But we saw that for the mutations, here in the document, to add a user, we need to send name, address, birthday, and posts. That we can see that the only required things are the name, address, and birthday. The posts are going to be optional. So we can test here to add a user, or we can just come here and start making our own. The thing is that the mutation is going to be something like this because we're going to send some variables, but on the options here, we're going to send also how we want to keep our cache updated. So let's just take everything as we have been doing. Let's check out. Well, we're going to need maybe this wait helper. So we paste here. We have, instead of the use query, as I said before, the only times that we're going to use a query is on the read part, but if we're going to create, update, or delete, we need a use mutation. So we define a const, add user. So this is less error prone. Add user, and we said that for this, we're going to need name, address, and birthday. We can come here, paste it. This is all the things that our query should receive. And down here, we're going to define the names of the variables. Sorry, this is going to be the value. And here we're going to say that on the name part of the query, we're going to use the variable name. And so on with the other ones that are required. Birthday, $, birthday. And so, as the documentation says, this is going to return us a user type that we just created if everything goes right. So we took the state out. This toast is from Chakra, is the little toast that appears here. And so we said that we need the name, the address, and the birthday. So the ID is going to be optional. We're going to delete it here. No, I'm not going to delete it on the form. I'm just not using it. And we're going to delete all of this stuff out. So the use mutation query is a bit different. The use mutation query is going to return a tuple, is that the word? Just like the state from React is an array destructuring, what we need, in which the first value is going to be the function that we need to run, that we could run when we want to do this mutation. Sorry. And the second part is our beloved object that provides us a loading state and an error state, if there's any. So we use the hook, use mutation, we pass as a first parameter the mutation, and as a second parameter an options object. In this case, we're going to need a we're going to define, let me check my notes. Oh, okay. The use mutation requires that you send an update function to keep the cache updated. We're going to name it update cache for now, and we're going to define it here outside. So we said that this has to be a function, and this function is going to get the cache as a first argument, and we can destructure the data on the second parameter. The cache has some functions to help us keep the status up to date. I cannot see any here, but we have the modify function that we're going to use. Let's just, let me first try to use the mutation, because you can use mutations without the updating the cache. This is optional, but we're going to see first why we need it. We're going to comment this, and we're on it later. So we said that we have the add user function that the use mutation returns, and we had to use it when we want to run that mutation. So when we press submit, we should trigger this function handleSubmit. And this is going to run this function that receives some options, an object with options. The options that we're going to pass are going to be the variables that this needs, which are going to be, as we had earlier, maybe we didn't see, this e dot target was it like this? Sorry.
Yeah, you have the target name, address, birthday.
Yeah, if we use the spread, it should make a key value with the values, but we're going to be, for the secure part, we're going to send the name with eTarget.name.value. I don't want any more trouble. A target address value, and birthday is going to be a.target.birthday.value. Okay, if everything goes right, loading doesn't exist, so it's loading, sorry. And we are not using toasts. If everything goes right, we can just call it toast. Oh, I should have get it from earlier. Well, we're going to check this right here. If we save this, we can see that if we try to create the user, oh, sorry, so much copying and pasting, I forgot the query. It should be a mutation. The ID is not necessary and not checked. Let's say that Ivan house 23 and the birthday is sometime. If we check the network, it seems like the update, the mutation was run okay. But the importance of updating the cache, well, Ivan is now here, but if we don't update the cache, we might not see it after we make this mutation. So let's just send, as we were saying, because if we don't do it now, we will have to do it later on the delete part. I said update. It's going to be cache update. And sorry, I found two ways to update the cache. One is to modify it using a fragment. It's like, this is going to be the new user, just add it. And the other way is fetch all the users and update the cache with this new array with all the users plus the new one. If I don't know how we are with the time, but we had like an hour and a half. Sorry. We're going to try both approaches. So to modify the cache, we're going to send an object as a parameter, as a first parameter with fields key that this is going to define on the users which field is going to be updated, and on the users we're going to pass a function. If we use the ES6 magic, we can do something like this, and it's the same as I did like this. So this function is going to receive the existing users, which we can default to an empty array. And we're going to define a const, which is going to be the new user, that it's going to, this user is going to be returned after we make a write fragment on the cache, because we are directly updating the cache with this fragment that we're going to define. So we said that this data is the data that we're going to get here from this variable, so this variable's object, when we use the add user helper function that use mutation return. So we have to say that the data on this fragment is going to use add user of this data, and the fragment that we're going to use to update this user is going to be a query, GQL. We're going to use we need to use the tag GQL, define a fragment with a name, and I don't know, new user, and where we're going to use it, on users. It's going to have an ID, name, address, birthday. We're going to pass we're only using 3 values, but we're going to pass every value just in case. And from the posts, we have the ID, title for every post, sorry, content, and comments. So when this is done, we need to return from this function this array spreading the existing users with this new user that is going to be returned from our of writing the fragment on the cache. This should be working. I didn't leave the toasts for feedback, but let's just save it. And now when we add another user, we should have our update function run, and this should update our cache when we check all users, another user. And lastly, we're going to check how to delete a user. This is something like we just did, but it comes with some other problems. let's just delete the weight, delete the state. We can delete the toast or leave it. We're going to try to use it now. Function get users. We're going to use this to get the users. Function delete me. Oh, this is horrible. And as we did just recently, we're going to need a mutation, but the mutation on this case to delete the user, if we check the documentation, we see that it only receives an ID of the user to delete and returns that string if the user was deleted. Pretty simple. We're on the delete user. Yes. So delete user. We're going to use a mutation. Mutation delete user. We're going to need the ID of type string and just run. Sorry?
Typo or no? Or no? Delete user?
Oh, this is just the name of the mutation.
No,
shouldn't be a problem. So this just returns a string, so we can run it like that, and it's going to be return. So what we have now is that first for in this case, we need to first fetch all the users to then choose one and delete it. But as we said here, as we said earlier, we need to only get the users, and we don't need, like on the JSON server, all the data from the users. We can just check which things to return, to query for, sorry. So we're going to take this from here, get users and delete user. This is the behavior of this component should be the same as get all the users at first. So we're going to use both use query and use mutation. And we can query our users here. The thing is that if we have data, error, and loading, if you use, as we saw, the use mutation, we're going to have also a loading and an error state from here. And delete user. And the second one is going to be update. So how can we avoid that? We can use an alias for the structuring and say that this loading is going to be the mutation loading. And this error is going to be mutation error. So when we use the use query hook, this is going to be run when the component mounts. So we don't need to use the use effect query. Sorry, hook. Oh, I deleted the toasties. Goodbye, toast. So now if we have if loading, we're going to be loading. And on the delete me function, we're going to run the helper function that we have to delete the user, which needs to be past the user ID. So what we can add to have feedback from the mutation, we can say down here, mutation loading, and add a spinner, for example, with a size of, I don't know, 24 pixels. And if there's an error with our mutation, we can just add a text here. You can handle the errors and the loadings better than this, but this is just to show this, how this works. So the users won't be here anymore. If we have an error from the first fetch, we can just return text error fetching users. We can just remove this check and this check. Oh, well, this can be for when we delete all the users. And we're going to just say data.user. So this should be it, but we need the way to update the cache, because as I said earlier, if we delete a user, we're not going to see the update when we check all the users again. This, I checked it earlier with the create mutation, and it didn't happen as I think, but with the delete, when I was testing this, I really needed to update the cache. So we're going to define this update cache. And we're going to use the other way to update the cache. As I said, we're going to read the cache. So we need the cache and the data, just as before, the data destructure. So we define existing users, and we get them from the cache read query, and we need to pass to this a query, an object with a query that is going to be the get users query. This is going to return to us all the users that we need. So now we have in new users all the existing users now, but we need to define a new users array, which is going to be an array with the just deleted user filtered out. So we're going to define a user, we receive a user, And we say when user ID is distinct of the data, delete user, which is the data that we receive here. We now have the new array to write our cache. Oh, sorry. Here, cache, write query. This receives an object with a query. Damn it. Get users to fetch all the users, and we're going to add data that is going to be an object with where the users is going to be an array with a spread of the new users. Whew. This should work. I hope so. Let me save. And now if we enter delete, we're going to have, oh, cache update is not defined. Oh, cache update is not the same as update cache. There. Now if we delete Ivan, oh, we had an error. And text, I was using text and it didn't exist. The mutation seems that maybe worked. No, Ivan's still there. We sent a bad request. Well, let me just change to the branch where this is working, and we can continue and see what we did wrong. So as I said, we get the use query, use mutation, define get users and delete user. And on the use query, I've used an alias to loading an error from the query, the first query. We define the update cache. Oh, it was defined inside, sorry, I was defining it outside. We read the cache, save it on existing users, filter out the user it was deleted, and we write the query with the query get users and the new data. I'm going to npm start this to just to see that we are now running the front-end part without the db.json with the JSON server, and this should work. So the use mutation gets the delete user mutation and the function update cache. Oh, I was sending wrong the variables. Well, if you send the ID, user ID, this should have worked. I was sending user ID only. But yeah, everything else should be the same. If there's an error of the query, if there's no length, when the mutation is loading, or if there's a mutation error. So let's now try, and Ivan is out. Now the another user is out. If we check our playground, we see that we deleted the users. And in our instance, we can see also that there is only one user now. This was just React. We're going to see that.
Sorry,
Yeah.
I interrupted you. Rose told me that we should get and then the presentation.
Okay. We can check on Angular. If we do npm run dev, we also have a JSON server working. And I'm going to just do a code tour on Angular. It's going to be quick, I promise. Sorry for the delay. Now this should localhost 42,000. Oh, I had to run this earlier, sorry. Well, in the meantime, we're going to see that a lot of things that we had to do manually here in React, in Angular is a lot simpler if we use Angular schematics. We take advantage of them. Oh, this is not going to work. Sorry, I forgot to install Angular as a global Angular CLI. Well, let me just do a code. Well, sorry for this. If we come to users, the first thing we have to do is install with Angular. We need to, oh, where is the text here? Sorry. For Angular, we first have to install with Angular ng add Apollo Angular. After that, if we install Apollo Angular, it's going to ask us on the CLI for the URI of our GraphQL server. And that's it. It will be configured instantly, and we don't have to do anything more than just importing Apollo from Apollo Angular and importing GQL from GraphQL tag. We also have this tag to help us do our queries. So we had here an HTTP request. We instantiate Apollo on the constructor, and then we do this Apollo watch query which gets an object with the query that we just did. And we have to subscribe to the value changes of this watch query, where we define if there are users, result data. If it exists, just save the users. The front-end part is kind of like the same of the React part, divided in chunks, in parts of read user, all users, one user. And then if we check out to the 02 read single, we can see on the user that it's pretty much the same as this. We import Apollo from Apollo Angular, GQL, and we define in the constructor, we instantiate root to get the root param, and Apollo to run the query. So if we do this Apollo watch query, this accepts an object as a first param, an object with a query and the variables that we need to send to this query, with the ID being extracted from the params. And then this is the same as before. This user, result.the user, this loading, result loading, this error, result error. We can check out to the create part. If we check the create user part, we're going to we had this function that got the form. We were using Angular forms, and instead of doing write query, we're going to use a mutate function to use a mutation in which the object that it takes will get the mutation that we can get from the React part, and the variables, which are going to be the form values spread. It's going to be the name, address, and birthday, which are the required stuff. And also, as a second parameter, we're sending an update function, which is exactly the same that we just saw with React. And this will keep our cache updated. We need to subscribe to this, get the data. If this success, we were checking that with this success true just to show a text if it was okay. And if there's an error, we can use the second part of the subscribe to send an error. And lastly, we have the delete part, which is the hardest part also, that we're going to extract the get users apart. We could have been doing this on the other components of Angular 2. We implement onInit on this one, and we will use onInit to run the query to get all the users, and another function to delete the user when we click every user with the ID. We destructure the ID, and as we just did, we run this Apollo mutate, which takes an object with mutation to run, the variables to send to that mutation, and an update function to keep the cache updated. We subscribe to this data. We just console log it because we just need to show the ID of the user deleted, and if there is an error, we can console log the error. Sorry that I couldn't show this. I forgot to install Angular before this presentation. And well, I think that should be it. Ivan, if you have anything to add.
No, on my end, you can go to the next slide. Well, if you know anything that we could improve, or if you have any question that you want to forward to us. Also, we are going to upload the repositories, the code. It will be available on the same link to the chat, to the link to this code. So, and you can write us if you have any questions on those emails, on our emails. So thank you everyone for assist, and have a nice weekend.